Hello students, in this video we'll prove the commutativity and associativity of addition on the positive fractions. So here's our first result. Our commutativity result says the following. It says that a over b, a positive fraction, plus c over d is equivalent to what? Is equivalent to c over d plus a over b. So let's prove this. So here's the proof of our commutativity. In other words, it doesn't matter what order I add fractions in. We're going to most likely exploit the commutativity of the of addition and multiplication of the natural numbers in the course of this proof. So let's see how it works. So the right-hand side of this is going to be what? The right-hand side, a over b plus c over d is equal to, or is equivalent to, AD plus BC over B times D. And now technically what I have to do is I have to write this. I'm going to now use the fact that addition is commutative. So since addition is commutative, I can write this as BC plus AD over, I'm going to use the fact that multiplication is commutative, D times B. And now I'm in good shape, but I need to see a c times b and a d times a. So I'm going to use the fact that addition, that multiplication is commutative, and write this as c times b plus d times a over d times b. And this exactly is equivalent to c over d plus a over b. And that shows us that addition of positive fractions is commutative. And that follows directly from what fact? It follows from the facts that addition and multiplication are commutative on the natural numbers. So all that legwork we did using induction of the piano axioms is helping us out now when we construct the properties of positive fractions, rational numbers, and eventually real numbers. Now let's do the next property, and that's associativity. Okay, what does that say? That says, now this is a little bit more work. This is a over b plus c over d plus e over f. So let's give e over f its own sort of runway over here. E over f is equal to a over b plus parentheses c over d. And again, we should say what? We should avoid using equals because we're talking about equivalences. So this is equivalent to what? C over d plus e over f. Okay? So let's do it. So here's the proof. Again, we're going to use associativity, commutativity over and over and over again on the natural numbers. So our proof is as follows. So the left-hand side, a over b plus c over d plus e over f is equivalent to what? Is equivalent to AD plus BC over BD. And then this is going to be added to what? Added to E over F, which is equivalent to what? AD plus BC times F plus what? Plus E, BD times E, all divided by BD times F, like so. Now, what we'll do is we can think of this. Well, the first thing we'll do is we'll take the D and the F and we'll put them together by associating them. So what this is equivalent to. So now I need to see a CF, and then I need to see a CF and then a DE. Okay, so I'm going to group those terms together over here. So by associativity, this is equivalent to what? So I need to see a CF, so that's going to be this term over here, and then a DE, that's this term over here. So by associativity, this is going to be what? By distributivity and associativity, this is going to be an ADF. And then plus, I'm going to associate that. I'm going to have a BCF plus BDE. So BDE all over what? All over, and I'm going to pull out the B and associate the multiplication. So this is going to be B times DF by associating that. And so now we're in a good shape over here, because now what do we see? Now, both of these terms over here, I can associate that and put the b on front, so I can use the distributivity property to say this is what? To show this is going to be A times df by associating that multiplication, plus what? By factoring or using distributivity, I can pull up that b plus b times cf plus, pulled out the b, so I have d times e over here, d times e, all divided by what? B times df. And now if we look carefully, what do we see over here? We see over here that what we're doing is we're really adding the fraction what? AB plus this expression over here, which is what? That is equivalent to CF plus DE over DF. And that's exactly what we see over here. So this is exactly is equivalent to A over B plus C over D plus E over f, and that shows that addition on the positive fractions is associative and commutative. Thank you very much.